Quadratic equations, an introduction. This is Kisembo Academy, and thanks for tuning in. What are quadratic equations? Now, before we get to explore quadratic equations, you need some background knowledge on the following. You need to know how to solve simple algebraic expressions such as this: 2a plus 1 is equal to 2, 2p plus 4 is equal to p, to find the value of the unknowns. You need to have mastered that. Secondly, you need to have mastered how to factorize algebraic expressions such as this on your screen. Now, if you have mastered how to factorize algebraic expressions such as this, then you are good to go as far as quadratic equations are concerned. On our screen, we are having a small boy, about 5 years old. He's urinating. So when he's urinating, he's going to direct his urine up, and that urine will move up and down, forming a curved shape, as you all see. Let's use another illustration. That same boy still kicks a ball. When he kicks that ball, it will move up into the air, reach somewhere, and then it will come back down. In both cases, we get to see that there is a shape that is formed, like a curve. Now, these curved shapes that you have seen that are being formed are called trajectories. Now, these trajectories you have just seen can be modeled by a mathematical function. This mathematical function is of the form of ax squared plus bx plus c. Now, this function ax squared plus bx plus c, this function is what we are calling a quadratic function. For example, right here we are having a quadratic function, 2x squared plus 4x plus 5, and we see that the value of a here is 2, the value of b here is 4, the value of c is 5. In other words, a, b, and c are always whole numbers, and it's always that function. This quadratic function it's called a quadratic function on condition that a is not 0. Now, when this quadratic function is equated to 0, then it is called a quadratic equation. So meaning, if I come and equate this thing to 0, then this quadratic function now becomes a quadratic equation. And in this video, we are going to start looking at how we solve quadratic equations. Now, when solving quadratic equations such as these, we are bound to get two solutions, or two values of x as our answer. Now, these two values of x, or these two solutions, are what we call the roots of a quadratic equation. So today we are going to explore, we are going to see how we get these roots with a few worked examples. Looking on our screen is a number, x squared plus 5x minus 6 is equal to 0. We are required to find the value of x. So what we do in this case, we are going to have to first factorize these quadratic expressions. We are going to find the value of x using the method of factorization of quadratic expressions. So we factorize. So in factorizing this expression, we are supposed to find two numbers giving us two terms. Two numbers. One of the numbers is supposed to give us a sum of positive 5, and the other number is supposed to give us a product of negative 6. Where do we get those two numbers from? We get those two numbers from by analyzing the factors of 6. So, what are these factors of 6? Factors of 6, we have 1 times 6. Now, between 1 and 6, if we made negative 1 a negative, we know that negative 1 times 6 will give us negative 6, because the negative and the positive will give us a negative. The negative 1 plus 6 gives us a sum of positive 5. So it means out of all the factors of 6, we shall go with these two numbers, negative 1 and 6. So we come, and this negative 1 and 6 are going to replace this middle term. So we begin our factorization. This becomes x squared minus x, this is minus 1x, minus x, plus 6, this is positive 6, so it is plus 6x, then minus 6 is equal to 0. Then we introduce brackets and factorize out. Common term here is x, so x is outside the brackets into x minus 1. The common factor here is 6, positive 6, so it's going to be plus 6 into still x minus 1 is equal to 0. And so definitely the terms outside the brackets will remain on their own, so it is x plus 6 in its own bracket into x minus 1 is equal to 0. So when we reach that stage, we have factorized this quadratic equation. Now, remember we have a property that any number that is multiplied by 0 is a 0. If you get 1,000 multiplied by 0, or it is 2 times 0, the answer you will get is 0. Now when you look at this expression, we have this bracket x plus 6 multiplied by x minus 1, we get 0. Now if this multiplied by that is giving us 0, it means that either one of these, either this thing is 0 or that is there. Because we are sure of one thing, that if you multiply anything by 0, your answer should be 0. So if the answer here is 0, so either this is 0 or that is 0. So to get our two values of x, we shall say that either x plus 6 is equal to 0 or x minus 1 is equal to 0. And of course, to get our value of x here, x will be, when 6 crosses goes that side, is negative 6, and here x is equal to 1. So these are the two roots, or the two answers we are talking about at the beginning of this video. I said that when solving quadratic equations, we are bound to get two solutions, and these two solutions, which in this case are negative 6 and 1, are what we call the roots of a quadratic equation. We have another example, x squared plus 6x minus 16 is equal to 0. We are going to solve that quadratic equation still by factorization. So how do we do the factorization bit here? Still, we are supposed to split this number into 2 so that we create the 2. We are splitting this into 2. How? We are supposed to find two numbers giving us a sum of positive 6 and then a product of negative 16. How do we get those two numbers? We get those two numbers by evaluating the factors of 16. Now among the factors of 16, we have 1 times 16, then we have 2 times 8. Now if you look at 2 and 8, 2 times 8 and 2 and 8, they are within the range, they can give us what we want. So if you manipulate these two to suit this, you find that if we made 2 a negative, negative 2 times 8 gives us negative 16. Negative 2 plus 8 gives us positive 6. So we shall go with these two factors of 16. So these are the ones we are going to use to displace this middle term. So it means after this, our next step is going to become x squared minus 2x. This is positive 8, so it is plus 8x minus 16 is equal to 0. Again, we shall introduce the brackets, and when we introduce the brackets, the common factor here is going to be x outside the brackets into it's going to be x minus 2, then it's going to be plus 8 into x minus 2 still is being equal to 0. So x into x minus 2 plus 8 into x minus 2 is equal to 0. You realize that the terms that are inside the brackets are the same. And so what we do, we put the terms outside the brackets in their own bracket. That is x plus 8 into the terms that are inside the brackets is x minus 2 is equal to 0. So at this point we have factorized this quadratic expression. Now the question is, one of these is 0, because this times that is giving us 0. So either this is 0 or that is 0. So to get the two values of x, we shall say either x plus 8 is equal to 0, or x minus 2 is equal to 0. And definitely here, when 8 crosses the equal signs, you have x is going to give us negative 8. And here, when this negative 2 comes that side, we have x as 2 as our answer. Again, we are going to look for the roots of this. We are going to look for two numbers in such a way that when we add them, they give us a sum of negative 7, and when we multiply them, they give us a product of 12. So what are these two numbers? Where do we get these two numbers? We get them by evaluating the factors of 12. So the factors of 12, among others, we have 1 times 12, that's a factor of 12. We have 2 times 6, then we have 3 times 4. So now when we look at 3 and 4, we can manipulate these to suit this. If we manipulate these two numbers, it can be in such a way that when we add them, they give us negative 7. When we multiply them, they give us 12. If we made 3 negative and this 4 negative, you realize that negative 3 times negative 4 is going to give us positive 12. Then also negative 3 plus negative 4 is going to give us negative 7. So when we add these two numbers, they give us a sum of negative 7, which is that. And when we multiply them, they give us a product of 12, which is that. So these are the two numbers we shall go with, and we use them to displace this middle term. So in displacing that middle term, it means that our next step is going to become x squared minus 3, minus 3x, then minus 4, because this is negative 4, minus 4x minus 4x plus 12 is equal to 0. You realize that negative 3 minus 4x is giving us negative 7. So we put these in brackets, even this one in brackets. So our next step, we go ahead and factorize. The common factor here between x squared and 3x is x, so we put x outside the brackets into x minus 3. Then here the common term here is negative 4. So we put negative 4 outside the brackets into negative 4x divided by negative 4 is giving us x. Then 12 divided by negative 4 is minus 3 is equal to 0. So from that point, we put the terms outside the brackets in their own bracket. So it becomes x minus 4 in one bracket. Then we put the terms in the brackets in another bracket also. In all the three numbers we've just done, you realize that the coefficient of x squared has been 1. If you look at this, the coefficient of x squared here is 1. The coefficient of x squared here is also 1. And the coefficient of x squared here is 1. Now in our next video, we are going to look at how we solve quadratic equations where the coefficient of x squared is not 1. How we actually factorize them. It's going to be more or less the same, but something new. So in our next video, we're going to look at how we deal with quadratic equations whose coefficient of x squared is not 1. Those are numbers to try out. In this video, we are going to look at how we factorize and find the value of x for quadratic equations where the coefficient of x squared is not 1. Before, we're dealing with quadratic equations where the coefficient of x is 1. So again, as we continue to factorize this, it means we're supposed to get two numbers. Those two numbers are supposed to give us a sum of negative 17. That is, when we add those two numbers, we're supposed to get a sum of negative 17. And when we multiply those two numbers, they're supposed to be giving us a product of 6 times 5. And we know that 6 times this 5 is giving us 30. So where are those two numbers going to come from? Again, those two numbers are going to come from the factors of 30. So let's evaluate the factors of 30. Now, from the factors of 30, we have 1 times 30 is a factor of 30. We have 2 times 15. Now, if you look at these numbers 2 and 15, we can manipulate them to suit this condition. If I made these two negative and this 15 also negative. Negative 2 times negative 15 will give us a positive 30, because we know that two negatives, when you multiply a negative by negative, you get a positive. So negative 2 times negative 15 will give us positive 30. So negative 2 plus negative 15 is going to give us negative 17. So it means the numbers negative 2 and negative 15 are giving us a sum of negative 17, and when we multiply them, they're giving us a product of 30. So we shall use these two numbers in trying to split this middle term into 2. So we continue with our working. So it means from here our next step is going to become 5x squared. Then now this middle term is going to be replaced by these two roots. So it's going to be negative 2x, that is minus 2x. Then negative 15x, that is minus 15x, then plus 6 is equal to 0. You realize that negative 2 minus 15 gives us negative 17. So this leads us back to that. So when we introduce brackets right here and there, we factorize out. The common factor here is x, so we put x outside the brackets into 5x minus 2. Then the common factor here is 3, so we put negative 3 outside the brackets into 15x divided by negative 3 will give us 5x. Then the 15x divided by negative 3 gives us positive 5x. Then 6 divided by negative 3 gives us negative 2. That is equal to 0. So you realize that we're having the same terms in the brackets, and we have this outside the bracket. So we put the terms outside the brackets in its own bracket, x minus 3 in its own bracket, into 5x minus 2 is equal to 0. So at that point, we have factorized this quadratic equation. So after factorization, then we go ahead and find the value of x. Since this times that is equal to 0, and we know that if you multiply any two numbers and you get your answer as 0, it means one of those two numbers is 0. Then it means that either this one is 0 or that one is 0. So it means we shall write and say either x minus 3 is equal to 0 or 5x minus 2 is equal to 0. And when we make x the subject of the formula here, we shall have our value of x as 3, and right here our value of x is 2 over 5. So the two values of x here are 2 over 5 and 3. Again, in this we are supposed to factorize this number. We are supposed to get two digits or two numbers. When we add these two numbers, they're supposed to give us a sum of positive 2, and also when we multiply them, they're supposed to give us a product of 3 times negative 5. 3 times negative 5 is negative 15. So how do we get those numbers? We get those numbers by exploring the factors of 15. So we'll begin with 1 times 15. It's a factor. Then we have 3 times 5. I think 3 times 5 will give 3 and 5 will give us what we want if we manipulate them. Now, if we made this 3 a negative, you realize that negative 3 plus 5 gives us a sum of positive 2. Then negative 3 times 5 gives us a product of negative 15. So these two numbers satisfy that condition. So because they satisfy this condition, so we are going to use them to displace this middle term. So our next step here will become 3x squared minus 3x. We are now displacing this middle term. So it's minus 3x plus 5x minus 5 is equal to 0. So this, we put brackets here and right there. So the common term, the common factor here is 3x. We put 3x outside the brackets into 3x squared divided by 3x here remain with x. The negative 3x divided by 3x will remain with negative 1. Then this is going to be plus, the common factor here is 5. We put 5 outside the brackets into 5x divided by positive 5 will give us x. Then negative 5 divided by 5 will give us negative 1 is equal to 0. So we put the terms outside the brackets, the terms, these ones, we put them in their own bracket, which is going to become 3x plus 5. We put that in their brackets. Then these terms that are in the brackets, we put them in their own bracket, is equal to 0. At that point, we have factorized it. This is here, this is a factorized expression of that. So after factorization, we go ahead and find the value of x. And so from this point, it is either 3x plus 5 is equal to 0, or x minus 1 is equal to 0. And when we make x the subject of the formula here, our value of x is going to be negative 5 over 3, and our value of x here, when we make x the subject of the formula, it's going to be equal to 1. So the two answers, or the two values of x for that expression, are negative 5 over 3 and 1. This brings us to the end of this video. Thanks for tuning in. Sometimes you'll be required to find quadratic equations to solve for the values of x or the unknown in a quadratic equation, but they won't be arranged in the way you know it, that ax squared plus bx plus c. In this video, we're going to look at how we solve quadratic equations that are not arranged in that form. The form I'm talking about is the standard form of a quadratic equation, which is ax squared plus bx plus c. We shall illustrate this with a few examples. This is Kisembo Academy, and thanks for tuning in. So we're being told to solve x squared plus 2x minus 7 is equal to 13 plus x. Now, definitely this is a quadratic expression or a quadratic equation because we have the highest power of the equation being 2, the highest power of x. So what we do here is we have to first arrange it into this form. After arranging it into that form, then that is only then that we shall go ahead and factorize it. So we'll begin our first task by first arranging it to this form. So arranging it, we'll have to make sure that this equation is equated to 0. It means that this 13 is supposed to come over, cross that equal sign. Likewise, this positive x also is supposed to come over, cross that equal sign. So we'll begin. It's going to become x squared plus 2x minus 7. Then this 13, when it crosses, here it was positive 13. When it crosses the equal signs, it comes this way, it becomes negative 13. So this is going to become minus 13. Likewise, this positive x, when it crossed this equal sign to come this side, here it was positive, now it's going to become minus x. That's all going to be equal to 0, because when these two come over this side, we leave there nothing. So when they all come this way, we start collecting like terms. So it's going to become x squared plus 2x minus x, so it's plus 2x minus x, then minus 7 minus 13. All this is going to be equal to 0. So x squared, 2x minus x is going to give us x, so it's going to become plus x. Then negative 3 minus 13 is going to give us a negative 20. All this is equal to 0. So at last, we have formulated a quadratic equation after rearranging. We formulate a quadratic equation that is in the form of ax squared plus bx plus c. So after formulating that, rearranging it to that form, then we can go ahead and factorize it. So of course, as we are factorizing this equation, we're supposed to look for two numbers first. These two numbers, when we add them, they're supposed to give us a sum of positive 1. And then when we multiply them, they're supposed to give us a product of negative 20. And we get these numbers by exploring the factors of 20. Now, amid the factors of 20, we have 1 times 20. These are factors of 20. 1 times 20 will give us 20. We have 2 times 10. We have 4 times 5. Now, if you look at 4 and 5, 4 and 5 can be used to manipulate. We can manipulate these two numbers to fit this condition. How do we manipulate them? Now, if we made 4 a negative, we know that negative 4 times 5 will give us negative 20. Negative 4 plus 5 will give us a sum of 1. So we shall go with negative 4 and 5. and we use it to displace this middle term using these two numbers. So it means after here, our next step is going to be x squared minus 4x plus 5x, because this is positive 5, so it's plus 5x minus 20 is equal to 0. So we'll go ahead and factorize. So factorizing this, put this in brackets, put that in brackets. The common factor here is x. So we put x outside the brackets into x minus 4. Then the common factor here definitely is 5. So it's plus 5 into, that's going to give us 5x divided by 5 is x. Negative 20 divided by positive 5 is negative 4. Is equal to 0. We put the terms outside the brackets in their own bracket, so it is going to become x plus 5 into x minus 4 is equal to 0. And of course, after factorizing them, to get the value of x, it's either x plus 5 is equal to 0 or x minus 4 is equal to 0. And when we make x the subject of the formula here, this 5 crossing coming that side, we remain here with our value of x as negative 5 as the answer. And then here when 4 comes this side, to make x the subject of the formula, our value of x is 4. We have another example. We have 2 into a minus 5 into a plus 5 is equal to 21a. Still, we are going to open these brackets and make sure that we rearrange this expression in such a way that it is equal to 0, so that we are able to solve it. So we shall begin first by opening these brackets. This is 2 times that bracket times that bracket. So we deal with those brackets first. So it's going to become 2 into, now expanding these brackets is going to be a times a is a squared, then a times positive 5 is plus 5a, then we have negative 5 times a is negative 5a, then we have negative 5 times positive 5 giving us negative 25 is going equal to 21a. Definitely this is going to become 2 into, now positive 5a and minus 5a is 0. These two will cancel. So you remain inside here a squared minus 25 is giving us 21a. So we open brackets here, 2 times a is 2a squared. Then 2 times negative 25 is giving us negative 50 is giving us 21a. So we shall end up with, when we transfer this, remember we want to equate it to 0, we transfer this to come this way, we remain with 2a squared minus 21a minus 50 is equal to 0. So we have formed a quadratic equation in A. So we go ahead and factorize this quadratic equation and find the value of A. Now, so if you had a quick mathematical eye, you would realize that this is an identity. A minus 5 into a plus 5 is an identity for difference of 2 squares. And with difference of 2 squares, after realizing this, you would just get from this step and come straight to this step without having to first expand the brackets, because a minus 5 into a plus 5 is the same as a squared minus 5 squared. This 5 squared is 25. So a squared minus b squared is equal to 5 squared. So in factorizing this number, we're supposed to find 2 numbers. Those 2 numbers are supposed to be giving us a sum of negative 21. And that is when we add them. They're supposed to give us a sum of negative 21. Then when we multiply them, they're supposed to be giving us a product of 2 times negative 50. And when we say 2 times negative 50, the answer we get is negative 100. So we are going to get those 2 numbers from the product of the factors of 100. So the factors of 100 here, we have 1 times 100. We have 2 times 50. We have 4 times 25. Now if you look at 4 and 25, they can give us what we, if we manipulate these two, they can give us what we want. If we made 25 negative, 4 plus negative 25 gives us negative 21. Then 4 times negative 25 gives us negative 100. So when we multiply these two, they give us a product of 100. When we add these two, they give us a sum of negative 21. So we'll go with these two. So this is going to, but we will use these two to displace this middle term. So this is going to become, our next step will be 2a squared plus 4a minus 25a. Now this serves to displace that, then minus 50 is equal to 0. So we go ahead and factorize, put these into brackets, these ones also into brackets. The common term, the common factor here is 2a, so we put 2a outside the brackets into 2a squared divided by 2a is a, plus 4a divided by 2a is 2. Then the common factor here is 25, so we put negative 25 outside the brackets. Negative 25a divided by negative 25 will give us a. Negative 50 divided by negative 25 will give us positive 2 is equal to 0. Of course, the terms in the brackets are supposed to always be the same. So with 2a minus 25, we put that in their own bracket. 2a minus 25 into a plus 2 is equal to 0. There we have factorized the expression, so we go ahead and find. So the value of a. So it's either 2a minus 25 is equal to 0 or a plus 2 is equal to 0. So when we make a the subject of the formula here, it's definitely 2a is equal to 25, divide both sides by 2. A will become 25 over 2, and likewise here when 2 crosses to come that side, we remain with our value of a as 2. So those are the two. X plus 5 is equal to 36 over x. So to begin this off, we make it a flat equation. So when we say this over 1, we cross multiply. So that will make it a flat equation. So it's going to be x times this whole part is equal to 1 times 36. So x times that is going to become x times x plus 5 is going to give us 1 times 36, which is 36. When we open brackets here, x times x is x squared, x times 5 is plus 5x is equal to 36. So we bring this 36 this way, it becomes x squared plus 5x minus 36 is equal to 0. So we have a quadratic equation that we have rearranged. So we have two numbers giving us, we're supposed to get two numbers to factorize this, giving us a sum of positive 5. And when we multiply those products, those two numbers, they're supposed to be giving us a product of 1 times negative 36, which is negative 36. So we get those numbers from the factors of 36. So we begin exploring the factors of 36. We have 1 times 36 as one of the factors there. Then we have 2 times 18. Then we have 3 times 18. Then we have 4 times 9. Now if you look at 4 times 9, if you manipulate these two numbers, and let's say you made 4 a negative. Negative 4 times positive 9 will give us negative 36. Negative 4 plus positive 9 will give us a positive 5. So these two numbers are satisfying this condition, because when we add them, they give us a sum of positive 5. When we multiply them, they are giving us a product of negative 36. So we shall use these two numbers to come and displace this middle term. So it means after here, our next step is going to become x squared. We ignore this and replace them with this, minus 4x plus 9x minus 36 is equal to 0. So when we group this and that, we go ahead and factorize them. The common factor here is x, so it is x outside the brackets into x squared divided by x is x. Negative 4x divided by x is giving us minus 4. Then right here, the common factor here will be 9x divided by 9 is going to give us x. Then negative 36 divided by 9 will give us negative 4 is equal to 0. Now you're supposed to do it in such a way that the terms in the brackets are the same. It's x minus 4, x minus 4. So we put the terms outside the brackets in their own bracket. So our next step will be x plus 9 into x minus 4 is equal to 0. So to go ahead and find the value of x, it's either x plus 9 is equal to 0 or x minus 4 is equal to 0. And our value of x here is negative 9, or our value of x here is 4. In our previous videos, when we were trying to find out the roots of a quadratic equation, we said that when we are solving quadratic equations, we are bound to get two solutions. These two solutions are what we call the roots of a quadratic equation. Now in this video, we are going to find out how we are going to find the quadratic equation when we have been given the roots. In other words, we are working backwards. Before, we've been trying to find the roots of a quadratic equation, and we've been finding those roots by factorization. Now we've been given the roots and we are going to be working backwards to see how we arrive back to the equation. This is Kisembo Academy, and thanks for tuning in. Let me use an illustration. If we are having one of our roots as q and one of our roots as p, as shown on your screen. When you have been given x is equal to p and x is equal to q, these are your roots. When you're working backwards, it means that you take this p back so that this is equal to 0. This q, you take it back so that x minus q is equal to 0. So it means that these are the two brackets that you dismantled before. So it becomes x minus p into x minus q is equal to 0. You go ahead and open these brackets. When you open these brackets, you end up with this expression as a result of multiplying this bracket with that bracket. When you end up with that expression and you rearrange it, you realize that you get the general expression in that x squared minus x into p plus q plus pq, whereby it is here you're having the sum of the roots and here you're having the product of the two roots that you have been given. So the general expression for a quadratic equation is that x squared minus the sum of the roots, x plus the product of the roots. We are going to demonstrate this. But before we demonstrate it, let's look at one of the numbers we have done and we try and follow through. If you look at this number we just did in one of our earlier videos, we've been given, if this is the root of 6 and that's the root of 1, it means that if the x is equal to 6 and x is equal to 1, it means that you're going to have to first take this back and this 1 back to get that step. X plus 6 is and x minus 1 is equal to 0. Then these two brackets, you're going to multiply them because this times that is equal to 0. Then now, when you multiply them, you're supposed to multiply these two brackets so that you get the first expression, which is that. We are going to demonstrate this with a few examples. So let's find the quadratic equation when you've been given when the roots of that equation are 3 and negative 1. Now when the roots of this quadratic equation are 3 and 1, it means that at first the value of x was 3 and also the value of x was negative 1. So we shift that 3 back here And of course, when it crosses the equal sign, it becomes x minus 3 is equal to 0. Likewise, here, when we shift that negative 1 to this way, it becomes x plus 1 is equal to 0. So now we have two brackets here. So we go ahead and multiply those brackets. So this becomes x minus 3 and x plus 1 is equal to 0. Now we open those brackets, so it becomes x times x is, it becomes x times that bracket, which is x times x plus 1, then minus 3 into that whole bracket times x plus 1 is equal to 0. So you go ahead and open the brackets. X times x is x squared, then we have x times 1, which is plus x, then you have negative 3 times x, which is minus 3x, then you have negative 3 times 1, which is minus 3, giving us 0. So we shall end up with the quadratic equation, which is going to become x squared positive 3 minus 3x is going to give us minus 2x, then minus 3 is equal to 0. Now that is the quadratic equation. We have worked backwards. Now if you wanted, you could still factorize this expression, and you realize that your working will be working towards getting those two answers. Now we said still, if they give you roots like 3 and negative 1, we can still use this expression that x squared minus the sum of roots, the product of roots, we must be able to get that same answer. If we are to evaluate it from this point, for example, let's assume that we have our roots, we've been given roots of 3 and negative 1. So let's substitute it direct here. It's going to be x squared minus the sum of roots. The sum of the roots is 3 plus negative 1. So it's minus 3 plus negative 1 x, then plus the product of the roots. So plus the product of the roots, which is 3 times negative 1. So which is 3 times negative 1. So you end up with x squared. Then 3 plus negative 1 is going to give us 2. So it's going to be minus 2x plus 3 times negative 1. 3 times negative 1 is minus 3. So it's minus 3. And you realize that x squared minus 2x minus 3, it's the same as this, x squared minus 2x minus 3. So whichever formula you use, you can use this expression, or you can decide and work backwards like the way we have done in this video. Solving quadratic equations using the square root property. We'll demonstrate this using some two worked examples. We have x squared minus 25 is equal to 0. We are required to find the value of x. What we do here, we'll go ahead and say x squared, with this is negative 25, so we bring it that way. It's going to be equal to positive 25. Now, to get the value of x, it means we're supposed to find the square root on both sides. So we find the square root of that and of that. Now, of course, this square root and that die, so we remain with x giving us. Now, the square root of 25, here it is 5, but this is either plus or minus. So it is either plus or minus 5. So it means x has two values. So x is either equal to 5 or negative 5. So as far as the square root property is concerned, we know that a square root of a number is either a positive or a negative. Why? Because 5 times 5 will give us 25. Negative 5 times negative 5 will still give us positive 25. So square root of any number is either a negative or a positive. So that's how we solve that. Let's do one more example. In our second example, we are required to find the value of p. Again, we are going to try to attempt. We first make p the subject of the formula, so it becomes 4p is going to be equal to this negative 1 comes that way, it becomes 1. So when we divide both sides by 4, this and that go, we remain with p squared giving us a quarter. But we are not interested in p squared, we are interested in the value of p. So to remain with p here means we are supposed to find the square root on both sides. And of course here the square root of a quarter is either a positive or a negative. And so here the square root of 1 is 1, because 1 times 1 is 1. The square root of 4 is 2. So it means we are going to either have positive or negative a half. So it means p is either a half or p is also negative a half. So those are the two values of p. In this quadratic expression, still we are required to find the value of x. Here we shall use the square root property still and solve for the value of x. We have x minus 4 squared is equal to 64. So to remove this square root square sign, we find the square root on both sides of the equation, so that this square root sign disappears with that squared sign. So you remain with x over minus 4 this way. So it means that x minus 4 is going to be equal to, remember that here the square root of 64 is 8, but it's either positive or negative. So the square root of 64 is, in this case, it's going to be positive or negative 8. So we'll continue with our value of x. So our value of x, when this 4 crosses to come this side, it's going to become positive or negative 8 plus 4. It means the two values of x here are either our value of x is going to be positive 8 plus 4, or it's going to be negative 8 plus 4. And definitely our answer here is going to be 12, and our answer here will be negative 4. So those are our four values. Those are our two values of x. X is either this or that. These are the two values of x for that quadratic expression. We'll do one more example. We have this x minus 3 in bracket squared minus 15 is equal to 0. Still, we are going to rearrange it. We are going to say it is x minus 3 squared is going to be equal to this negative 15. Shift it to that way. It was negative 15 here. When it crosses the equal signs, come this way, it becomes a positive 15. And so when it becomes positive 15, we are bound to find the square root on both sides. So this goes with that. We remain with x minus 3 here is going to give us the square root of 15. Now the square root of 15, remember, it's either a positive or a negative. So it's either plus or minus square root of 15. So when this 3 is to come this way, it was negative 3, it becomes positive. So we have a value of x giving us plus or minus the square root of 15 plus 3. So we have two answers. Either x is equal to, let's say, 3 plus root of 15, 3 plus the square root of 15, or it is 3 minus 15, 3 minus the square root of 15. And definitely our two answers, these are our, you can go ahead and simplify them, or you can just stop here. And these are your answers for that. In our next video, we shall be dealing with completing squares, where we shall be applying some of these. So in circumstances whereby we cannot easily get the roots of a quadratic equation, we employ a method called completing squares. Now, completing squares is a method we use. It's a technique we use to make this side of the equation a perfect square, so that we are able to go ahead and calculate the value of x. Now, what is a perfect square? Let me show you a few examples of what I mean by a perfect square. If you look at that number here, if we are to factorize this number like we've been doing in our previous videos, we are supposed to get two numbers giving us a sum of 10 and a product of 25. And where do we get these two numbers? We get these two numbers from the factors of 25. And one of the factors of 25 is 5 times 5. 5 times 5 gives us 25. So from 5 times 5, you find that we are able to get 25. Then 5 plus 5 gives us 10. So we use these two numbers, 5 and 5, to come and replace this middle term. That is why in our next step, it is x squared plus, we ignore this middle term, and we say it is 5x plus 5x, then plus 25. Then we introduce brackets here and there, which is in our next step. And then we factorize this. X comes out of the brackets. X squared divided by x gives us x. 5x divided by x gives us 5. Then also likewise, the common factor here is 5. So 5x divided by 5 is x. Then 25 divided by 5 is 5. So you end up having x plus 5 in one bracket, then the terms in the brackets in another bracket. And you realize that it is x plus 5, which is the same term, and we end up having x plus 5 squared. So because we're having x plus 5 squared, it means that the roots of this quadratic equation is the same. It is 5. So this makes this quadratic expression a perfect square. It is the same in our next expression. We are still going to get two numbers to factorize this. Those two numbers should be giving us a sum of negative 18 when we add them, and also when we multiply them, they are supposed to give us a product of 81. And we get these numbers from the factors of 81, and one of the factors of 81 is 9 and 9. So 9 times 9, negative 9 times negative 9 gives us 81. Negative 9 plus negative 9 gives us negative 18. So you realize that these are the two numbers, the roots. So these two, negative 9 and negative 9, are going to displace this middle term. When they displace that middle term, it means that from here, our next step is going to become x squared. Instead of putting this, we shall come and say it's minus 9x plus 81. Then we introduce brackets, and we go ahead and factorize this. The common factor here is x, so it is x into x minus 9. Then likewise here, we factor out the 9. It is minus 9 into x minus 9. So the terms outside the brackets are put in one bracket. The terms inside the brackets are put in their own bracket. And you realize that it's x minus 9, which is the same as x minus 9 squared. So you find that we are having, this quadratic equation is having the same root, which is 9 and 9. So it means, because we have x minus 9 squared as the factorized expression of this quadratic equation, it makes this quadratic equation a perfect square. So now, back to our earlier number. When you're having a number like this, whereby we are trying to look for these two numbers, we are trying to look for these two numbers that are supposed to displace this middle term. We are trying to look for them, but we have failed to get them. When we fail to get them, then we do what we call completing squares. Now, when we complete squares, we attempt to make this side of the equation to become a perfect square. When we make this side of the equation a perfect square, then we are able to solve this quadratic equation simply. So our main purpose of trying to complete squares is simple: to make this side of the equation a perfect square. And when we make this side of the equation a perfect square, then we are able to solve the quadratic equation and find the values of x. So we'll go ahead and begin our working. So in our working here, our first step is, first we are supposed to make this x go that side. So this is going to become x squared plus 10 is going to be equal to, this negative 7 comes this way, it becomes 7. So this is 10 squared plus 10x. So from that point, this is what we do. We are going to look at the coefficient of x, which is 10. We divide it by 2. When we divide the coefficient of x by 2, then we are going to the answer we get, we square it. After squaring the answer we get, we add it on both sides of this equation. When we add it on both sides of this equation, you will realize that in this part of the equation has become a perfect square, and when it becomes a perfect square, then we can solve the quadratic equation. So we shall begin. We have 10x. 10x, so we get the coefficient of x, which is 10. That is 10. Divide 10 by 2. When we divide 10 by 2, we get 5. So the answer we get, we square it. So 10 divided by 2 is 5. 5 squared is 25. So the answer here we are getting is 25. So what do? We get this 25 and we add it on both sides of this equation. So from this point we shall say it is going to be x squared plus 10x plus 25 is going to be equal to 7 plus 25. And then from there we realize that finding the sum and product of this, factorizing this expression, we need to look for the other two numbers, giving us a sum of 10 and a product of 25. And of course the two numbers here are 5 times 5, because 5 times 5 is 25. 5 plus 5 is 10. So we come and use them to displace this middle term. So this is going to end up being x squared. Instead of that we say plus 5x plus 5x plus 25 is going to give us 7 plus 25, which is going to give us 32. So when we put this in brackets and that in brackets, we factor out this is going to be x out of the brackets into x plus 5 into, factor this 5 outside the brackets into x plus 5 is equal to 32. So you realize that from this point we are having x plus 5 into x plus 5 is equal to 32. So this becomes x plus 5 squared is equal to 32. Now you realize that when we did this, we made this side of the equation a perfect square. It's a perfect square that is equal to 32. So we go ahead and find the value of x by employing the square root property. So it means for us to find the value of x means we are going to find the square root on both sides. Of course, square root of 32 is either a positive or a negative. So this square root sign dies with that. You remain with x plus 5 being equal to plus or minus the square root of 32. So definitely from this point we have x plus 5 being equal to plus or minus the square root of 32. And of course, when this 5 crosses to come this way, you remain with either x giving you 5, this is negative 5, plus or minus the square root of 32. So in this case, either x will be equal to negative 5 plus the root of 32, or our value of x is going to be negative 5 minus the square root of 32. So we are going to solve this quadratic equation by completing squares. When we are completing squares, our first step will be x squared minus 8x is going to be equal to, this 2 has to cross to come this side, so it becomes negative 2 on that side. So we'll begin again. We look at the coefficient of x. Now this coefficient of x, we are going to first divide it by 2. When we divide it by 2, the answer we get is negative 4. Now the answer we get is supposed to be squared. When we square the answer, the answer we get is 16. So it is this 16 that we are going to add on both sides of this equation. So it means our next step is going to be x squared minus 8x. Then we shall add the 16 we got here is going to be equal to negative 2 plus that 16. Now, the reason as to why we do that is, in so doing, we have made this side of the equation a perfect square. So we'll continue working in that light. So factorizing this equation means that you're supposed to get two numbers to split this middle term into two. The two numbers should be giving us a sum of negative 8, and when we add those two numbers, they're supposed to be giving us a product of 16. And in identifying those two numbers, you realize that those two numbers are 4 and 4. Because 4 times 4 was going to give us 16, but if we add 4 plus 4, will it give us negative 8? No. So if we make this a negative and that a negative, negative 4 plus negative 4 gives us negative 8. Negative 4 times negative 4 gives us positive 16. So the numbers here are negative 4 and negative 4. So negative 4 and negative 4 are the ones that are going to replace that middle term. So it means our next step is going to be x squared minus 4x plus 16 is going to give us negative 2 plus 16, which is 14. So definitely when we introduce here brackets, the common factor here definitely is going to be x into x minus 4. Common factor here is still going to be negative 4 into negative 4 divided by 4 is going to become x minus 4 is going to be equal to 14. And of course the terms outside the brackets here are what we put them in their own bracket into the terms inside the brackets, which is x minus 4 is going to give us 14. You realize that this is x minus 4, which is the same as saying x minus 4 squared is equal to 14. Now this is a perfect square. X minus 4 squared is what we got, was derived from this. So we go ahead and find the value of x using the square root property. So the value of x here is going to be, we find square roots on both sides to eliminate that square sign. When we find the square root here and the square root here, this goes with that. Of course, x minus 4 is going to be equal to the square root of 4, which is either a positive or a negative. So it means this is going to become x minus 4 is going to be equal to the square root of 4, which is either positive or negative, square root of 14. So this has to come that side. So you remain with the value of x as it's going to become positive 4 plus or minus the square root of 14. So from here we have two values of x. Either our value of x is going to be equal to 4 plus root of 14, or our value of x is going to be 4 minus the square root of 14. And those are our two values of x. Now from this number you will notice that when we are trying to complete squares so that we make this side of the equation a perfect square, when we do so you realize that at this point, when after we've shifted this negative 2 to come this side and we are remaining with 8, it means when we divide 8 by 2 we get 4. Negative 8 divided by 2, when we divide it by 2 we get negative 4. So this number we get after we have divided, you can simply come and say it is going to be x minus 4 squared. So it means we can avoid this step by simply saying that when we are after this step we can say it's going to become negative 8 divided by 2. The answer we get is what we call is negative 4. So we come here and say x minus that number 4 squared is equal to 14, and we avoid these steps. It's the same with the number we did before. If you look at the number we did before, it's still the same thing. If you look at this value of 10, we said it is 10 divided by 2. 10 divided by 2 we get 5. So it means it's going to be x plus 5 in brackets squared, which is what we got here. So it was x plus 5 squared, and we continue with our working. I'm going to demonstrate this in our next example. In our next example, we are required to solve that number while completing squares. So this definitely is equal to 0. So solving that using completing squares, it's still going to become x squared minus 3x is, so x squared minus 3x minus 1 is equal to 0. So we are going to complete squares. Completing squares here means that we're supposed to first put it in this form. It means -1 cross this equal signs to come this way. That's how we end up with x squared minus 3x is equal to 1. The 1 is this way. So from this level, we divide both sides by, we see the at this level we see the coefficient of x, which is -3. So we see -3. We divide it by 2. Of course, -3 divided by 2 is going to be equal to -1.5. So for us to get the perfect square here is -3 divided by 2 to get 1.5. So this -3 over 2, after dividing the coefficient of x by 2, we simply come here and say it's going to be x. -3 divided by 2, it gave us that, so it's going to be -3 over 2. All this squared is going to be equal to the answer we got here, which is -1.5. We're supposed to square it. Of course, when you square it, this is 1 plus 3 squared is 9. -3 times -3 is 9. Divide that by 2 times 2, which is 4. I want to relate this to some of the numbers we did before. If you look at this number here, if we were at this level, it would simply have been, from that level, it is 10 divided by 2. What is 10 divided by 2? It is 5. So it would simply come from this level, would say it's going to be x plus 10 divided by 2 is 5. Then we simply say this is squared, is going to be equal to 7 plus now this 5 squared. 7 plus 5 squared, which is 25. Like that. And this is the same level here. Would avoid all this. So it's what we're trying to do here as we are completing squares. The shortcut here would be that this number divide by 2. So it's going to be -3 over 2 squared. Then it's going to be equal to 1 plus this term squared. And that term squared is 9 over 4. And the rest is just arithmetic. So we're going to find the square root of that number on both sides to try and get the number. So it's going to become the square root of this side and that side. This goes with that. We remain with x minus 3 over 2, giving us 1 plus 9 over 4, which is x squared plus 10x minus 6 is equal to 0. Now we're meant to solve that number using completing squares. I'm going to use the shortcut. So this is going to become x squared plus 10x is going to be equal to this 6. Moves this side, it becomes positive 6. So what we do here, it's going to become, we have 10 here, 10x. So it's going to become x plus 10. 10 divided by 5, 10 divided by 2, dividing this by 2 means you're going to get 5. So it's going to become plus 5, and this is going to be squared, is going to be equal to 6. Then 6 plus, you square this. What is 5 times 5? 5 times 5 is 25. So it's going to be plus 25. So you've completed squares. So the rest is obvious. 6 plus 5 squared is going to be equal to 6. This is going to be 21. So when you find the square root on both sides, this is plus or minus, this goes with that. You remain with x plus 5, giving you plus or minus the square root of 21. So here, when this 5 goes that side, you remain with your value of x giving you negative 5 plus or minus the square root of 21. So you have two values of x. X is either negative 5 plus root of 2 of 21, or the value of x here is negative 5 minus the square root of 21. Actually, 6 plus 25 is 31, so it is actually root of 31, not 21 like I had earlier said. It's 31 here and 31 right there. As we solve this using completing squares, we are going to have to convert this thing to come that side. So it's going to become x squared minus 12x is equal to 3. So you look at this number, the 12, the coefficient of x, which is negative 12. What is negative 12 divided by 2? Negative 12 divided by 2 is 6. So it is negative 6. So it means that the answer here will be x. Negative 12 divided by 2 is negative 6. And this is squared. That's the perfect square from this. It's going to be equal to 3. Now 3, we are supposed to add this number squared. So negative 6 squared is positive 36. So it's plus 36. So of course the answer we have here is x minus 6 squared is going to give us 39. We find the square root of the number on both sides and get our values of x. Further worked examples on completing squares. We get to look at this. 2x squared plus 8x minus 6 is equal to 0. Now before, we've been dealing with quadratic equations whose coefficient of x squared was 1. But now here it is 2. Now we have to first make sure that the coefficient of x squared is 1. So it means we're going to divide through by 2 throughout. So that these 2 and that 2 cancel and you remain with x squared plus 8 over 2 is 4, which is 4x, minus 6 divided by 2, which is 3, is going to give us 0. Now after making sure that our quadratic equation has its coefficient of x squared as 1, then we can go ahead and complete squares. So like we've been doing before, it's going to become x squared plus 4x is going to give us 3. So we look at the coefficient of x divided by 2. 4 divided by 2 is 2, so it's going to become x plus 2, because this is positive 4. Positive 4 divided by 2 is positive 2, so it's x plus 2, and this becomes a perfect square, is going to become 3. Then we're supposed to add plus this with this number squared, 2 squared. The answer we've got here, squared. So this is plus 4. So this is going to become x plus 2 squared, giving us 4 plus 3, which is 7. When you find the square root on both sides, this goes with that. This is plus or minus. So you remain with x plus 2 being equal to plus or minus the square root of 7. So our value of x is either negative 2 plus the root of 7, or it is negative 2 minus the root of 7. These are our two values of x. We do one more example. We are going to employ the same technique. The coefficient of x squared there is not 1, it is 3. We have to first make sure that this coefficient of x squared is 1. So what do? We divide through by that coefficient, which is 3, throughout the entire equation. So that when we cancel this 3 and that 3, we remain with x squared here alone. So x squared minus 15 divided by 3 is 5. So it's minus 5x. Then minus 2/3 is still going to be equal to 0. So we shall shift this, take it that side. So this is going to become x squared minus 5x is going to give us 2/3. So once it's giving us 2/3, then we shall look at the coefficient of x. The coefficient of x here is negative 5. So what is negative 5 divided by 2? we'll get an answer or a decimal number. So it will leave it as negative 5 over 2. So this is going to become x minus negative 5 divided by 2. This whole thing is squared. Is going to be equal to 2 over 3 plus this squared, the number we have, this term squared. So it's going to be negative 5 over 2 squared, giving us 25 over 4. And definitely our answer here is going to become x minus 5 over 2 squared is going to be giving us 83 over 12. So when we find the square root on both sides, we realize that this is going to cancel with that. Here we have plus or minus. So we have x minus 5 over 2 giving us plus or minus the square root of 83 over 12. And so the answer here of the value of x will be, of course, when this 5 over 2 crosses to that side, we have 5 over 2 plus the square root of 83 over 12, or we have 5 over 2 minus the square root of 83 over 12. These are our two values of x. And up next is more of this. I urge you to stay tuned in. For more videos, please remember to subscribe. This is Arnold Rangakurumia on behalf of Kisembo Academy. How to derive the quadratic formula. This is Kisembo Academy, and thanks for tuning in. Right on your screen, you're having the general form of a quadratic equation. Ax squared plus bx plus c is equal to 0. That's the general form of a quadratic equation. Now we are going to use that general form of a quadratic equation to derive the quadratic formula. Now, when we are deriving the quadratic formula, we are going to attempt to solve this general form of the quadratic equation by completing squares. So we are going to complete squares here. And through completing squares, the expression we shall come with as the value of x will be the expression for the quadratic formula, the general quadratic formula. So what we do here, first of all, when we are completing squares, we always have to make sure that the coefficient of x squared is 1. Now, if the coefficient of x squared is not 1 or something else, it means that you're supposed to first divide through all these terms by that coefficient, so that here it is 1. So it means here in our next step, we are going to divide through here by a. So we divide through by a here, by a, by a, by a, so that this a and that a are able to cancel out. You remain with x squared plus b over ax plus c over a being equal to 0. So from that point, we are supposed to take this c over a, that side of the equation. So it becomes x squared plus b over a is going to be equal to negative c over a. Now, this b over x, b over ax. So we look at the coefficient of x, which is b over a. Now, the coefficient of x, which is b over a, divided by 2. If we are to divide this by 2, b over a. B over a divided by 2 will give us b over 2a. And then afterwards, so it means our next step, just like we've been doing it in our former videos, the coefficient of x here, we are supposed to divide it by 2. And b over a divided by 2 is equal to b over 2a. So after dividing this by 2, it means that the square here, our perfect square, is going to become x plus b over 2a. And this is going to become squared. Is going to be equal to negative c over a. And now we are going to add here plus the square of what we got here. We divide by 2, then what we get, we square it. And what we square it is what we add here. So this squared is going to become b squared over 4a squared. So it means that here, if we are to rearrange this, it's going to become b squared over 4a minus c over a is going to become x plus b over 2a. This whole thing is squared. So we use the square root property. We are trying to get the value of x, so we are trying to make x the subject of this formula in this whole expression. So square root on both sides, this goes with that. We shall remain with x plus b over 2a, giving us, now this becomes under the square root. Now the LCM of 4a squared and a is 4a squared. So 4a squared divided by 4a squared is 1. 1 times b squared is actually b squared. Then 4a squared divided by a is 4a. 4a times c is negative 4ac. So it means our next step here is actually x plus b over 2a is giving us, all this thing is under the square root of b squared minus 4ac over 4a squared. So at this point, so this definitely, this term is going to move to that side. And when it does, we remain with our value of x this way as being negative b over 2a under the square root. Now remember, this square root is either a positive or a negative. So it's positive or negative b squared minus 4ac over 4a squared. And of course, this will become negative b plus or minus. Here, the square root of this whole thing is the same as the square root of the numerator and the square root of the denominator. So to find the square root of the denominator, the square root of 4 is 2 and the square root of a squared is a. So this downer part will simply become 2a. So what we remain with here is under the square root of b squared minus 4ac, divide all that by 2a, because the square root of 4 is 2, the square root of a squared is a. This is over 2a. And of course here the LCM here is going to become, when we add, this is either plus or minus. So either plus or minus. To find the square root of this, to simplify this further, the LCM of this, to simplify this further, is 2a. 2a divided by 2a is 1. 1 times negative b is negative b, plus or minus 2a divided by 2a is 1. 1 times this whole issue, this whole bit is going to give you the square root of b squared minus 4ac. That is going to become x. So it means that according to this quadratic formula of ours, when we are solving quadratic equations, we always have two solutions. Either our value of x, this means that our value of x will either be negative b plus the root of this, plus the root of b squared minus 4ac over 2a, or our value of x will be negative b minus this, minus the square root of b squared minus 4ac, divide all that by 2a. So this is how we derive the quadratic formula, and it is the general formula we shall be using to solve a few quadratic equations. In our next video, we will be looking at how to solve a few quadratic equations using this quadratic formula. Thanks for tuning in. For more of these videos, I encourage you to subscribe. For Kisembo Academy, this is Arnold Kuramia. How to derive the quadratic formula. This is Kisembo Academy, and thanks for tuning in. Right on your screen, you're having the general form of a quadratic equation. Ax squared plus bx plus c is equal to 0. That's the general form of a quadratic equation. Now we are going to use that general form of a quadratic equation to derive the quadratic formula. Now, when we are deriving the quadratic formula, we are going to attempt to solve this general form of the quadratic equation by completing squares. So we are going to complete squares here, and through completing squares, the expression we shall come with as the value of x will be the expression for the quadratic formula, the general quadratic formula. So what we do here, first of all, when we are completing squares, we always have to make sure that the coefficient of x squared is 1. Now if the coefficient of x squared is not 1 or something else, it means that you're supposed to first divide through all these terms by that coefficient, so that here it is 1. So it means here in our next step we are going to divide through here by a. So we divide through by a here, by a, by a, by a, so that this a and that a are able to cancel out. You remain with x squared plus b over ax plus c over a being equal to 0. So from that point we are supposed to take this c over a, that side of the equation. So it becomes x squared plus b over a is going to be equal to negative c over a. Now this b over x, b over ax. So we look at the coefficient of x, which is b over a. Now the coefficient of b of x, which is b over a, divided by 2. If we are to divide this by 2, b over a, b over a divided by 2 will give us b over 2a. And then afterwards, so it means our next step, just like we've been doing it in our former videos, the coefficient of x here, we are supposed to divide it by 2. And b over a divided by 2 is equal to b over 2a. So after dividing this by 2, it means that the square here, our perfect square, is going to become x plus b over 2a, and this is going to become squared, is going to be equal to negative c over a, and now we are going to add here plus the square of what we got here. We divide by 2, then what we get, we square it, and what we square it is what we add here. So this squared is going to become b squared over 4a squared. So it means that here, if we are to rearrange this, it's going to become b squared over 4a minus c over a is going to become x plus b over 2a. This whole thing is squared. So we use the square root property. We are trying to get the value of x, so we are trying to make x the subject of this formula in this whole expression. So square root on both sides, this goes with that. We shall remain with x plus b over 2a, giving us, now this becomes under the square root. Now the LCM of 4a squared and a is 4a squared. So 4a squared divided by 4a squared is 1. 1 times b squared is actually b squared. Then 4a squared divided by a is 4a. 4a times c is negative 4ac. So it means our next step here is actually x plus b over 2a is giving us, all this thing is under the square root of b squared minus 4ac over 4a squared. So at this point, so this definitely, this term is going to move to that side. And when it does, we remain with our value of x this way as being negative b over 2a under the square root. Now remember, this square root is either a positive or a negative. So it's positive or negative b squared minus 4ac over 4a squared. And of course, this will become negative b plus or minus. Here, the square root of this whole thing is the same as the square root of the numerator and the square root of the denominator. So to find the square root of the denominator, the square root of 4 is 2 and the square root of a squared is a. So this downer part will simply become 2a. So what we remain with here is under the square root of b squared minus 4ac, divide all that by 2a, because the square root of 4 is 2, the square root of a squared is a. This is over 2a. And of course here the LCM here is going to become, when we add, this is either plus or minus. So either plus or minus. To find the square root of this, to simplify this further, the LCM of this, to simplify this further, is 2a. 2a divided by 2a is 1. 1 times negative b is negative b plus or minus 2a divided by 2a is 1. 1 times this whole issue, this whole bit is going to give you the square root of b squared minus 4ac. That is going to become x. So it means that according to this quadratic formula of ours, when we are solving quadratic equations, we always have two solutions. Either our value of x, this means that our value of x will either be negative b plus the root of this, plus the root of b squared minus 4ac over 2a, or our value of x will be negative b minus this, minus the square root of b squared minus 4ac, divide all that by 2a. So this is how we derive the quadratic formula, and it is the general formula we shall be using to solve a few quadratic equations. In our next video, we will be looking at how to solve a few quadratic equations using this quadratic formula. In using the quadratic formula to solve quadratic equations, we are supposed to make sure that we rearrange our equation in such a way that it is in this form. Now, in instances where it is already arranged in that form, we just go ahead and substitute. Now, if you look at this formula, it is already in that form, that this is ax squared plus bx plus c. And our value of a, according to this formula, our value of a here is 1. Our value of b is positive 3. And our value of c is negative 6. So from our formula, it means to solve for these quadratic equations by using that formula, it's going to become our value of x, we substitute in this formula, which is negative b over b plus or minus so it becomes negative b, our value of b is 3, it's negative 3 or plus or minus b squared, which is minus 4, times our value of a, which is 1, times our value of c, which is negative 6, divide all that by 2a. Our value of h is 1. And the rest is math. Our answer will be negative 3. So our values of two values of x are either negative 3 over 2 plus root of 33 or this. And those are our answers. Let's go ahead and solve the next. We have 4x squared minus 7x minus 15 is equal to 0. Again, we are going to rearrange it in this form. It's supposed to be in this form, x squared plus bx plus c. But right here, it's already arranged in this form. So what we do, we are just going to substitute into this formula. So in this, this is our value of a is 4, our value of b is negative 7, and our value of c is negative 15. So this is our value of c, our value of b is negative 7, our value of a is 4. So we go ahead and just substitute in right here. Our value of b is going to be negative b is 7, so it's negative, plus or minus b squared, our value of b is negative 7, so it's negative 7 squared, minus 4 times our value of a, which is 4, times our value of c, which is negative 15. All this we are supposed to divide by 2a, which is 2 times our value of a, which is 4. So the rest is just arithmetic. So negative and negative is give us a positive 7, plus or minus We're supposed to solve that number using the quadratic formula to get the values of x. This is Kisembo Academy, and thanks for tuning in. Looking at the expression on our screen, it is not arranged in the way it's supposed to be. From our previous videos, we said that if you are to use the quadratic formula to solve a quadratic equation, it's supposed to be rearranged in this form: ax squared plus bx plus c. So it means for us to be able to solve this number, we're supposed to first rearrange it to look like this. Then from then we shall be able to find the values of a, the values of b, and the values of c. Then it is from that point that we shall be able to substitute those terms of a, b, and c into the quadratic formula, and then we are able to get the answers. The quadratic formula we're talking about here has been derived in our previous videos, and it goes like this. So we are going to first rearrange this to look like this. So looking at this, we are having a fraction 6 over x. So we first make it a flat equation by multiplying through by x. So we shall multiply by x here, and by x there. So it means from this stage, our next step is going to be this. We'll go with that. So you remain here with 6 minus 2 times x is minus 2x squared is equal to 9x. So you shift this 9 to come this way. This is going to become negative 9x. When the 9 comes this way, it becomes negative 9x. Then it finds this 6 plus 6 minus 2x squared is equal to 0. So you rearrange this equation to look like this: ax squared plus bx plus c. So the ax squared is this. So it's going to be minus 2x squared plus bx. Our bx is this, negative 9x, so it's minus 9x plus c. And our value of c is positive 6 plus 6 is equal to 0. So looking at this, it means that our value of a is that, negative 2. Our value of b is negative 9. And our value of c is positive 6. So we substitute this in this expression. So substituting these terms a, b, and c in our equation means that our value of x is going to become negative b. Our negative b is negative 9, so it's negative 9. Plus or minus, so it is plus or minus into the square root of b squared. B squared is negative 9 squared, so it's going to be negative 9 squared minus 4ac minus 4 times our value of a, which is negative 2, times our value of c, which is positive 6. Divide all this by 2a. Our value of 2, it's 2 times our value of a, which is negative 2. And the rest is just arithmetics. So this is actually our value of a is our value of b is negative 9. So it is negative b. So this is supposed to be negative b, which is negative 9. So definitely negative times negative is positive. That's going to become 9 plus or minus everything that is inside there. So the answer we get there is either 9 plus root of 129 over negative 4, 9 plus the square root of 129 over negative 4, or it's going to be 9 minus that, 9 minus the square root of 129 over negative 4. These are our two values of x.